All right, so let's begin. I hope you can see my screen. Since I won't be able to see the participants, so please confirm by saying it. Hello? Hello? I'm somehow I'm feeling like I'm lost. Can you confirm that? Are you able to? Just a minute.
Yes, ma'am.
Yes.
Okay, okay. Okay, the screen is visible, right?
Yes.
All right. So, okay, so this is question one. We will discuss some of the assignment question and some of the question myself made it. So let's do some questions. Okay. So question one is, suppose OP and OQ be two vectors in R2, as you can see in the Cartesian plane, and we want to see what is the sum of these two vectors and what is the difference of these two vectors, and we want to see these vectors geometrically. Okay, since we do not know explicitly what these vectors are, but we have some geometric representation. So we want to see the sum. How does the sum look like on the Cartesian plane, and how does difference look like? So can any one of you can help me how to see this? Yeah, I somehow want full participation from you guys. So please speak something. Yeah, if you want some hint,
Um,
I can. Yeah, tell me.
we can complete the parallelogram. Like we can draw a vector parallel to OQ and OP, and then the intersection we
Mm-hmm.
can extend a line that is the diagonal of the parallelogram. So that will be OP plus OQ.
Right. So let me draw it. So as you told me, I'll just do the same. So solution. So you said we complete the parallelogram first. So let's complete the parallelogram. I'll try to draw in. I could. Okay. So I think this is what you wanted to say. The diagonal is going to give me the sum of P plus OQ, right? And what this is about OP plus OQ. What can you say about OP minus OQ?
That is the other diagonal.
Other diagonal. You mean this?
Yes.
Okay. How to see that?
Um, uh, how to see in the sense?
Yeah, you mean like we know addition is because of you complete the parallelogram and see the diagonal, right? So by meaning that OP minus OQ, what we are trying to do is OP plus minus OQ, right? So we are taking the vector in the other direction, right? I mean, I just want to make sure that you understand what is OP minus OQ. It's just not the anti-diagonal, but how did we get it? Hmm?
We the mirror of
Yeah,
complete the
so
parallel.
right. So if this is a direction towards OQ, then what will be the direction towards minus OQ? Can you tell me that?
Like will be good in the third quadrant.
Yeah, so it will be just the opposite to this, right? So this will be minus OQ to me, and now I know how to add two vectors, right? Right. So then simply I will again complete the parallelogram, and then diagonal is going to give me the OP minus OQ, right? And this is why what you were saying earlier is this, right? This and this are same, right? The direction also same and the magnitude is also same. So therefore, either you say it's the opposite diagonal or you draw it in this fashion that you use the fact that you are actually using the sum of two vectors, right? Is this okay? Like how to see the sum and difference of two vectors on the Cartesian plane?
Yes.
Okay, this is okay, right? I assume it's okay. Let's continue. So suppose we have two vectors given v and w, and we want to sketch these vectors. Okay, so v is given in certain
Somebody
direction
has
here. Sorry,
somebody has written in the chat that some participants are waiting.
some participants are waiting. Check. Okay, is there all of the students who are waiting, are they in the meeting now? Yeah. Can please anybody can confirm that? Are they here? The students who are waiting in the meeting, are they here in the meeting now? Uh, I have allowed all the people who are waiting, so I hope people are here. Okay, let me continue. So I hope the screen is still visible. So we were doing this question. So we have two vectors OP and OQ that I have just drawn in this R2 plane, and we want to see how to sum two vectors or how to take the difference of two vectors. Yeah, this is the first binary operation that we see. So we saw that if we want to sum up two vectors, we have to just complete the parallelogram, and the diagonal is going to give me the sum of OP and OQ. But if you want to see OP minus OQ, we have to just take the direction of OQ in the reverse. Like you just take the mirror image by along the x-axis, and therefore your vector which was in the first quadrant, that will go to third quadrant, and there you will complete the again parallelogram and look at the diagonal thing, and that will give you your vector. But if you see that vector is same as the other diagonal of that the first parallelogram which we saw for summing up two vectors, right? So this is what we did for the first question. Okay, now this is second question. So suppose v and w are two vectors which I am writing like this. So they have magnitude as well as they have certain direction, and we want to sketch these vectors 4 times vector w, 2 times vector v plus w, 2 times vector v minus vector w. So can you please help me how to sketch these vectors?
Like for
Yeah. Okay, let me draw this first. Okay, let me just draw that what are the vectors we have. So I think if I'm drawing correctly, so this is my vector v, and this is my vector w, I think. Okay, this is our plane. We want to see what is 4 times vector w. We can also see without drawing this Cartesian plane, even then we can see, but let's see through plane. Okay, what is 4 times vector w? I mean, it's a simple thing, I think. If you think about and please do respond. Are you all with me?
Uh,
Yeah.
Ma'am, extending this vector 4 times.
Right. So if suppose this is the length of the vector that I have written, how so direction will that change or no?
No, it wouldn't change. It will remain. Ma'am, someone else is also waiting in the lobby.
Okay, let's just. I'm somehow not very good at using all these things. So. Okay, I hope that whoever is waiting, he is now in the meeting. Okay, let me continue now. All right, so what we are doing is we have these two vectors. We want to compute the sum of certain vectors and certain scalar multiple of a vector. So 4 times vector W, as some student pointed out, we have to just add up, like we have to just increase its length by 4 times, right? Suppose this length is whatever the length, let's say norm of W, or absolute value, whatever you say, I will just have to add up 4 many times. So 1 time, 2 time, 3 time, and 4 time. So finally, this is what the final, this is what is going to be our vector 4 times W, right? This is fine now. So what is 2 times vector V plus W? I know it's a simple thing, but let's do it once. Maybe it's a simple, but you still can say, right?
Ma'am, extending the vector V twice and then adding it to W using the parallelogram law.
Okay, so I'll just remove what was 4 times W because this what we saw. This is what our vector 2V is. Now, what is the parallelogram? If you see, the parallelogram is by using the direction of W, you will get another vector, and using the direction of U, you will get another vector which is parallel to V and W, and therefore you will get a parallelogram. And now, which direction will I get the sum, right? Can you tell me, is this diagonal or this diagonal? First one or second one?
The first one.
Right, the first one will give me the sum of the vectors. So if you see, this is nothing but our sum of 2V plus W, right? So this is how we can sum up the vectors over R2 plane, right? So basically, if you want to sum up certain vectors which are written in form of R2 elements, then you can use the geometry itself to tell the sum and difference and the scalar multiplication. Now, same thing, what can you tell me about 2V minus W? I think you can see within this graph itself, like where is 2V minus W?
Ma'am, we just reverse the direction of 2V along the vector 2V itself and then add it using the parallelogram law and we'll get the other diagonal.
Other diagonal, right? So this is 2V minus W. Yeah, so either you want to do it, if you want to see this vector in this form, that you want to reverse the direction of W, so you can do it like this also. This is your minus W. Anyway, 2V remains the same. Now you want to add these two, so you will simply complete this parallelogram and see this is your diagonal. But if you see this vector and this vector, they are same, right? So therefore, you either of you can use the any of the way you can use to get the sum or the difference of the vectors. So I hope now you can compute any of the sum or difference or scalar multiplication of any vector. Okay, so far so fine. So yeah, so there is one definition we saw that vectors are said to be equivalent if they have same magnitude and same direction. Okay, so suppose we know this definition now, when two vectors are equivalent. So now let's try to do this question 3. So we have certain vectors that I have written, and we have to see whether they are equivalent or not. Okay, can you tell me first vector? Suppose a vector has initial point 3, 2. We are working in R2 only, and final point is 7, 2. Another vector whose initial point is 1, minus 4, and final point is 1, 0. You have to check whether these two vectors are equivalent or not. Can you see that? Of course, you have to draw these vectors in order to see that. Please, everyone, please try drawing on your notebook somewhere, and can you please tell me, are these equivalent or not? Remember, the definition of equivalent is magnitude as well as direction. Both have to be same. Any answers? Okay, can you help me in drawing? Okay, let me try doing here. Is anybody waiting? Okay, just give me a minute. Let me check if anybody is waiting. I think some students are joining right now. We have already started the session. I request you to please join on time so that you will not miss the certain things, because now we have done few questions. All right. So first thing, V and vector V and W, are they equivalent? Yeah.
No, ma'am.
They are not equivalent. Okay, how? What thing is wrong? Is the direction wrong or the magnitude wrong? What is going on?
They have the same magnitude, but the directions are not the same.
Okay, can you help me in drawing this? Okay, let me draw. Okay, so the first vector I have to draw. First vector is 3, 2. It's the initial point, and the final point is 7, 2. Yeah, so which direction I have to go?
From 3 to 7 2.
Right,
So
so this is the direction.
positive x.
Right, and where is the point? 1, minus 4. It's right here, and we have to go to point 1, 0. Where is that?
On the x-axis.
Exactly, it's this point, right? So if you see, what is the magnitude of these two vectors? Yeah, how long are these vectors? You can clearly see the distance. So here, and
Magnitude 4.
yeah, magnitude is 4, correct. And but if you see the directions, both have very different directions, right? So therefore, they are not equivalent vectors, although their magnitudes are same. Can you check the second thing, second part? So first part, not equivalent.
Ma'am.
They are equivalent?
Yes, ma'am.
Okay, so let me check. Okay, let's draw. What is the first vector?
V vector 0, 0, 0 to 1, 1.
Okay, it starts from 0, 0 and ends at 1, 1. So this is the vector. Is this okay?
Yes, ma'am.
What is the other vector?
-2, 2 to -1, 3.
-2, 2, 2. So this is a vector to -1, 2. Sorry, let me check. -1, 3. Okay. Yeah, I think roughly this is the diagram, right?
Both have same magnitude and direction.
Right. And what is the magnitude?
1.
All of you agree that magnitude is 1? Yeah. So what is the distance they are covering? They are only covering 1 unit, right? So magnitude is 1. Yeah, somebody said it's correct. And direction is also same. Even if they are not, I mean, the vectors, they don't have to overlap, okay? It can happen that somewhere vector is here, somewhere vector is there, but they have same direction, same magnitude, so therefore they are equivalent. Right. So in this case, this part is equivalent. This part is not equivalent. Okay, I hope this part is clear. Let's go to another question. So we have these certain diagrams that I have just written. So which one of them are equivalent? Which one of them are not equivalent? Okay, let me write certain number to these. Okay, now can you tell me?
Ma'am, I guess 2 and 6 are equivalent.
2 and 6 are equivalent. Okay. All of you
And
agree?
3 and 5 are equivalent.
3 and 5 are equivalent. What about 1?
I guess 1 and 3 also equivalent. 1, 3, 5.
Yeah, I think the way I have written, there is a minor difference, but yeah, the way I wanted to say is that yes, all are equivalent. So all of you agree that they are equivalent? I think still someone in the lobby. It's very difficult to go and switch and okay, I hope now everybody's here and I don't have to admit any other student. Please join on time. This is my only request. Okay, so yeah, all of you can see now that second and 4 are equivalent. But if I ask you second and third, are they equivalent?
No, ma'am, direction, magnitude also differs.
Right. So these are the only pairs which are equivalent. Remaining any other pair, they are not equivalent. All right. So I think that you understand what is the meaning of being two vectors are equivalent. All right. So yeah. So here we want to say something. Let's see what we are trying to learn. So we will understand one fact and then we will go to the question. Suppose we have V is a vector which has initial point xi, yi and final point xf, yf. Then we can describe our vector V in terms of a component form. Component form, like if you see any element of R2, if you try to write it, okay, without writing on a Cartesian plane, if you want to write without drawing Cartesian plane, you have to write in form of tuple, right? This is how an element of R2 looks like. So given a vector having initial and final point, I want to write that vector as an element of R2. So the way is that you take a difference with the final point with the initial point. And the difference you have to make sure it is component wise. Like the first component is xf, the first component for initial point is xi, and you have to take the difference. Similarly for the second component, and then you will get a tuple. Okay, and we will see why we are doing this. Okay, very soon we will see what is the purpose of doing all this. So if you understand what is the meaning that how to express an element is an R2 by components. So question is, suppose given vector has initial point minus 3, 4, terminal point is 1, 2, that is final point. So can we describe this vector in component form? What will be the component?
Four minus two.
4 minus 2. Okay, let me try to see. Our final point is 1, 2, and we have to take difference with the minus 3, 4. And difference is how? We have to do it by component wise. So 1 minus minus 3 and 2 minus 4. So we will get 4 comma minus 2. Yes, this is our component. Now, why we want to see is that the answer you will get why we are doing all this is by drawing it. Okay. So let's draw these vectors and try to see. So can you help me in drawing these vectors? So let me draw it. This is our x plane. This is our y plane. Now let's draw this vector 1, 2. Okay, so let's draw the vector whose initial point is minus 3, 4. So minus 3, 4 will be somewhere here, and initial and this final point is 1, comma 2, which is here. Yeah, you can see. So our vector is this. I'm bad at drawing, but this is what I want to say. So it starts from there and end it here. I'll write in the vector form. This is our vector v. Okay, initially this is what is given to us. Why we want to write as a difference with the final and initial point? Because if you see the final point 4 comma minus 2, where is that? You see this, and if I try drawing from origin to this, are these vectors same? I mean equivalent. What I mean to say is equivalent. Are these vectors equivalent?
Yes, ma'am.
They are equivalent, right? Because the magnitude is 4. Exactly 4 is the magnitude, if you see, and the direction is also same. But we are writing this component form because we want to present our vector. I mean, the way we want to represent it, it's starting from origin only. Okay, so we always work on a component form because we want to represent that vector starting from origin. This is why we want to write the component form by taking the difference so that that vector gets shifted to origin, and there we can draw it to the point where I will get the component form. So the whole purpose of doing this component form is to draw any vector from origin, not from any other point. So I think what I want to convey is, I think that should be okay. If you have any doubt, you please ask. Because if any R2 vector we are writing a comma b, let's say, then we always draw from origin. Okay, so wherever this point is, I'm just writing any random point. This is why that vector, if initial final point are different from origin, we just somehow translate it to um, certain form, so that it will start from origin, and this is the way that you just take the difference from the final and initial point. Okay. So yeah, so if I ask you that, suppose I have vectors which are not in R2, which are in R3 or R4 or higher dimension. So since we cannot see them geometrically, so the whole purpose of showing this geometrical meaning is that we and doing this all these things is that we can translate all those geometrical ways to algebraic ways, and finally we will apply algebraic operations. So, and we understand what are the operations of addition, multiplication, scalar multiplication, so that we don't have to see them geometrically because we cannot see them. And therefore we see that if two vectors are given, suppose it is x1 y1 x2 y2, and it is nothing but coordinate form. Okay, then we can sum up two vectors without looking at what is the geometry of those vectors. Okay, and the sum is nothing but component wise sum. You have x1 first component, x2 first component for v and w, you sum up them. Same thing if you have any scalar, if you want to scale up your vector, just like we saw, we scaled up our vector by 4 times, right? This is one of the example. We saw it geometrically, but suppose I don't want to see it, I want to write as a vector in R2. Then I should know that how to write it, okay? And the meaning is you just scale your both the components by k. If you want to write k times v, you have to scale both the components by k. Okay, so therefore algebra helps us to perform operations on higher dimension, which it's sometimes very hard to see in geometry. And this is why we are trying to perform operations like this. All right, so here is another question. So suppose vector is 6, 8. Now this is nothing but the coordinate form. Another vector is minus 2, 4. What is the norm? Is this, what do you call this? Norm or absolute value? Yeah. Do you have this meaning of or this kind of thing? Or maybe magnitude? What do you say? I think you people must be knowing with the magnitude. Um, Sorry, am I here? Sometimes we write like this also. Are you guys with me? Are you following?
Yes, ma'am.
Okay. So this is what I mean is the magnitude of vector v. However you write either one time modulus or two times. Okay. So what is the modulus of v where v is 6, 8? Can you tell me?
Magnitude 10.
Sorry?
10.
10. Okay, right. Magnitude is 10. All of you are getting 10? Okay, can you tell me how did you do it? Like what exactly you did in order to compute magnitude of v where v is 6, 8?
Square root of 6 square plus 8 square.
Alright, so if I write any vector, general vector with v1, v2, how would you write magnitude of v?
It is square root of the first component square plus the second component square.
Exactly right. So just following this thing, which we agree that this is exactly the formula. So therefore you have 36 plus 64, which is just square root of 100, and this is exactly 10. Yeah, so we are getting 10. Answer is correct. But now we want to compute what is v minus 2 times w. What is this? How would you compute? Like, do you want to compute it geometrically or the way we saw this algebraic operation now? Because we have components, now we know how to sum, how to take the difference, how to take the scalar multiplication. Hmm? Okay, so let's do by algebraically. Okay, since we just now saw the definition of summing up two vectors. So let me write w is minus 2, 4. Okay, meanwhile you also try. My pencil battery is. Okay, by the time you tell me what is this vector v minus 2w. Anyone?
10, 0.
10, 0. I think yes, 10, 0 is correct answer. All of you are getting the same answer?
Yes,
By
ma'am.
the way, how did you do it? Like, did you perform algebraic operation or you saw through geometrically? Like, can you tell me?
Just algebraic.
Right. So this is most easiest way. So let's do it now. So W is nothing but minus 2 comma 4 and B is nothing but 6 comma 8 and we want to compute B minus 2W. Simply it is 6 comma 8 minus 2 comma 4 and what we saw is whenever scalar multiplication is coming on a vector you just multiply this both the components, okay? So it will be minus 4 and then 8 and 6 comma 8 and therefore your first now addition, now this is kind of addition and you do it. So it is 6 plus 4 and 8 minus 8, so it is 10 comma 0. Or you can also do geometrically since we know this. So you can simply draw your vector v. V is nothing but 6 comma 8, so you have to go bit okay, so somehow this is my 6 8 and of course now since we whenever we write a vector in coordinate form your vector has to be represented from starting from origin, okay? This is how what we understand. Minus 2 comma 4 minus 2 somewhere is 4 here, okay? So then this is your another vector again starting from origin. Now you have to do what you have to do is the sum, okay? So you again complete the parallelogram, see the sum. This is how you will get the sum. But okay, sorry, we don't want to do the sum, we want to do something else. It's a bit tedious, like you have to, I think you have to do it till here and then minus, okay, I leave, I think it's a bit complicated to draw here. So you have to do, this is twice of W, you reverse the direction, either reverse the direction or reverse the diagonal also. So I think you know it, yeah, I'll just leave it. Okay, you can do it in either of the way, okay? Okay, another thing is 3 times v. So it is simple. Can you quickly tell me what is 3 times the vector v? 3 times 6 comma 8. We saw any scalar multiplication is by like you multiply that vector to the first component as well as the second. So it is 3.6 comma 3.8. It is just 18 comma 24. Is this okay? Okay, nobody is responding somehow. Okay, so there are certain facts which I want you to notice here. If we have vector addition, then it is commutative. Commutative in the sense, either you add v to w or you add w to v, the meaning is same. So it will give you the same vector, same direction, same magnitude. And it is associative. This property is we call as associative. This property is what we call as commutative. So either you add vectors uv and then add w, or you first add v and w and then add u to it. It just gives rise the same answer. So this is associativity. If you add zero vector which has which has certainly no direction, no magnitude, so it will just keep the vector same. It will not change it. If you have vector u, if you have vector u minus u, then if you add up, then you will get 0. Can you see this geometrically? Okay, so this is a question for you guys. Since how would you complete the parallelogram? Okay, so let me draw it. What I want to say here. Suppose you have a vector u, and what is minus u?
Ma'am, it's the vector along this vector, but it's facing the origin.
Mm-hmm. Is this what you want to say?
Yes, ma'am.
Okay, how would you add up and say 0? Of course, if you write in a component form, suppose this is vector this, then clearly your vector minus u is just minus a minus b. If you sum up these two, this you will get 0, 0. But can you say it geometrically? Alright, so I'll just give you this is a small homework. Let's discuss this in the next tutorial. So think about it, okay? And we have some more properties that if you have one scalar multiplying to the vector, you multiply another scalar, then it is same as multiplying both the scalars and then multiplying to the vector. And there are some more properties that if you can see, if you multiply your vector with 1, it will remain the same. Same thing with 0 and like other many properties. So these are certain properties about vectors. Okay, let's go to assignment questions. So this is your first assignment question. Your vector is 3 times I cap. What is the meaning first of all? Can you tell me what is the meaning of writing this vector in this form? What are these I cap, J cap, K cap?
The so like one I cap is just 1 comma 0 comma 0, J is 0 comma 1 comma 0, and K is 0.
Right. See, these are the unit vectors in R3, and sometimes they are the standard unit vectors we say. Okay, so recall, I'll just first recall what are these. Recall I cap is just 1 0 0, J cap is just 0 1 0, and K cap is 0 0 1. Okay, knowing this, can you tell me this vector in the coordinate form? And where and in which space this does this vector lie? Is it in R2?
It will be 4 minus 12.
Sorry?
It will be 3 4 minus 12 in R3.
Right. So it's a vector in R3, and this is how its coordinate look like. Now, what is the magnitude of vector V? This is what we call magnitude. We saw magnitude for a vector in R2. What about in R3?
Ma'am, it will be square root of 3 square plus 4 square plus minus 12 square, which turns out to be 13. Yeah,
Okay,
169.
exactly. This is 13. Very good. Okay, so we understand what is the meaning of vector. First of all, we understand how to see the magnitude. So far, so good. Let's see another question now. So I have written one statement. We have two vectors, and suppose assume that these vectors are in R2. Okay, although it can be in any space Rn. Assume they are in R2, and we are computing V minus W one side and then taking its magnitude. Another side we are taking the sum of the magnitudes of two vectors. And what we are saying is this inequality true? Yeah, can you verify this?
Yes, it is triangle.
And how would you give a proof for this, by the way?
It can be written as mod norm of v vector minus of into minus w vector. So it can be then
Sorry, I'm not following. Can you be slow? Can you be slow? Yeah.
so we have v vector w vector
V minus
vector.
W.
Okay, vector that
Mhm.
can be again written as v vector plus
Mhm.
into minus times w vector.
Correct.
And then we can now apply triangle inequality on this thing.
Okay, let's apply triangle inequality. What does the triangle inequality say?
A vector plus b vector is less than equal to mod of a vector plus b vector.
Okay, so for you, this is one vector and this is another vector, right? You have to say that this is your another vector. Okay, so we are applying then this is nothing but this plus your vector is now this. But what is the mod of minus time a vector?
No, again we have to again like take that minus one out. So any a vector dot b
Mm-hmm.
be written as norm dot b vector can be again written as norm of a vector dot norm of b vector.
Mm-hmm.
So then we have to calculate the norm of just minus one.
Right. Either you say this way or you can also check a norm of a vector and its negative is always same. Okay, this is, you can say it. Either you say that minus can be taken out, take the modulus and then take the vector, but this is exactly 1. So either of the way you can say. So it's clearly, it's true that this is same as v plus w. All right. So therefore this inequality is basically correct. So this answer is this true? Yes. Okay, very good. We have another question. So vector is here given with initial point this and terminal point is this. Okay. So can you tell me what is the vector which has this initial point and this final point and what is its magnitude? This is simple. I mean, everything is simple.
The vector is 4 comma minus 3 comma 0.
Okay, how did you compute? First tell me, maybe that. So let's solution. Okay. Are you writing the vector in coordinate form?
Yes.
Okay, so how to write the coordinate form? As we discussed, it is the terminal point minus initial point. And how do you write this terminal point in the coordinate form?
4 comma minus 3 comma 0.
4 comma minus 3 comma 0. I think this is what you want to say the final vector, but I'm right. I'm saying about initial points. So initial point, how would you write in the let's say in R3 as an element of R3?
Minus 1 comma 2 comma 1.
1, right? But you have to take the difference with the terminal point first. So let me write terminal point first. So 3 comma minus 1 comma 1. Take the difference. This is exactly, I think you will get minus 3 and then 0. Yeah. So this is your vector in coordinate form. But suppose I want to write a vector in terms of I, j, k cap. How would you write? Can you tell me how do you write 4i?
4 I cap minus 3 j cap plus 0 k cap.
Yeah, 0 either you write or you don't write. Okay, what is the magnitude? I think it's a simple. So 16 plus 9, which is just root 25, which is same as 5. Okay, so these questions are kind of repetition. So, okay, let's go ahead. One vector is given to us is I cap plus j cap. Another vector is just j cap. What is the angle between A and B vectors? You have to draw these vectors in order to see the angle between these two. Okay, let me also tell that these vectors are in R2. So this is in R2. Anybody? Answers?
Ma'am, theta is cos inverse of 2 over root 5.
2 over root 5.
Yeah. Uh, no.
I doubt. Maybe you check once again.
1 over root 2. Sorry. Yeah.
Okay, so your theta is cos inverse 1 over root 2. What is this? Can you recognize this value? If you remember, what are the cos values on 0, 30, 30 degree, 45 degree, 90 degrees and all? Can you see this value appear somewhere?
45.
Yeah, it's cos 45. So cos inverse cos 45. This is just 45. Okay, this is one way. By the way, who told you to do this? Can you please tell me how did you just somehow got your theta by cos inverse?
Ma'am, I think I made a mistake, but I'll tell you the formula. So, the formula I used is dot product.
Mm-hmm.
So, A dot P is mod A mod B cos theta.
Mm-hmm.
So, theta turns out to be A dot P over mod A mod B and cos inverse of that.
Exactly. And can you tell me what is the dot product of A and B?
It is 1 times 0 plus 1 times 1. So, it is 1.
Okay, so for you, dot product is just nothing but you have to
Component. Yeah.
components wise, right? 0 time
Yeah.
I plus j cap, and this is by modulus. What is the modulus of A?
Root 2.
It's root 2. And what is the modulus for J? B? I mean,
1.
1. Exactly. So this is nothing but your 1 over root 2.
Oh, so I was
Right.
right.
So correct. So your this is nothing but your cos theta. You are right. So therefore theta is 45 degree. Correct. But if you want to draw it, okay, these things you can very easily draw, right? This is just in R2. So let's draw it and then see that what exactly it will be. First vector was your I cap plus j cap. Can you write this vector first of all in the coordinate form so that you can draw here? What is this vector?
1 comma 1.
It's 1 comma 1. So let me just write 1 comma 1. And what is the other vector?
0 comma 1.
So let me write once again. B is just a j cap, and j cap, remember, this is 0 comma 1. This is 1 comma 0 plus 0 comma 1. All right, so 0 comma 1, where is this vector? It's, I think it's here. Sorry, here. It's correct, right? 0 comma 1. Okay, what is the angle between? If you can see that this vector is exactly at, can you tell what is the angle between this and this?
It is 45.
Yeah, either you can write, find it. How would you find this? So this is your, not sorry, not A. cos theta mod A sin theta. Sorry, I think I changed. This is sine, this is cos. And also, this is your 1 1. You know that. Therefore, you can tell me what is mod. So, mod is just root 2. And therefore, you can see that mod A cos theta is just 1 from here. Therefore, cos theta is just 1 by root 2, which is exactly your theta is 45 degrees. And if this angle is 45 degrees, you know that this whole angle is 90 degrees. So what is the angle between this vector? This is your vector B, this is your vector A. So what is the remaining angle? It has to be 45 degrees, right? Is this okay? Yeah, I'm just using some geometry by representing a vector. So if you see, if you have any vector which I'm writing A, then this part, I think I'm just highlighting. Yeah. So this part is just nothing but the mod times mod A times cos theta. This time is just nothing but mod A times sin theta. But you know that the distance is nothing but 1. Okay. So therefore you equate it to 1 and get your cos theta. Is this okay?
Yes, ma'am.
All right. So there can be many ways to handle this question. Angle is 45 degree. All right. So another question is, if you have two parallel vectors, what is A cross B? This is the cross product of two vectors. This is some quick question.
I'm 0.
This is
Zero
Why?
vector. Zero vector. Yeah.
Answer is 0. Yes. Yeah.
So formula wise,
Yeah,
it
please
is
go ahead.
mod A mod B sine theta. So theta would be 0, including n cap, and sine theta n cap. So theta is the angle between the vectors A and B because they are parallel. So the angle will be 0. So sine 0 is
All right.
0. Yeah.
Exactly. So since the two vectors are parallel, so therefore the angle between the two vectors is nothing but 0, and therefore your cross product comes out to be 0. Very good. All right. So I think all of you could do the assignment question. So very well. Let's
Excuse
continue
me, ma'am.
doing. Sorry. Yeah.
Ma'am, that in the videos also I watched, but can you just once explain me the geometric interpretation of cross product?
Cross product. I am not pretty sure how to draw it geometrically. Okay, maybe I
Like
will see and tell you next time. Sorry.
like in the videos, like they were like the instructor was saying something about rotating a corkscrew in one direction and something. So I didn't actually understand what that was about.
Okay. So, okay. Right now, I also don't know how to say it. Maybe. Okay. Maybe I will come to your answer in the next tutorial. So, please come to the next tutorial. I'll answer your question. Okay. Sorry, I somehow I don't know how to say it now, but I will for sure answer your question in the next tutorial. Okay, I'll just write that how to see geometrically. A cross B as well as A dot B. I will show both. Okay. Okay. So let's go ahead. This is another question. I think I already told you this answer. Let's do it again. Let's say. So we have one vector which I'm representing here. This is vector V, and this is its mod. You may call it just single one-time modulus. I have written double modulus. And we want to compute what is this and what is this. Uh, I'll just give a hint that it is nothing but your trigonometric ratios. Somehow from there you should be able to see it. Can any one of you please tell me like how to see this? If you remember a vector here, v is nothing but mod, I'm just writing one time now, mod v cos, sorry, sine cos, mod v cos theta, mod v sin theta. Right, so this is your first coordinate, this is your another coordinate. Suppose I tell you this, can you tell me now what is x and y? X is nothing but the just that the distance from 0 to the point. If I project that vector to the x-axis, then just the first vector, right? So let me just write it geometrically more clearly. Let's say if you have a and b, can you tell me what is this distance from here and what is this distance from here to here? If I project this vector to the x-axis, what will be the projected vector?
A comma 0.
A comma 0, right? Simply that. And if I project, suppose here, this vector, suppose here, what will be the coordinate there then?
B comma 0. Sorry, 0 comma B.
0 comma b, that's all. So therefore, if you want to know the distance, this one, okay, then this distance and this distance, I will just highlight. This distance and this distance are same, right? So if you know this distance, which you know it is b, this is also b, right? And same thing, this becomes just a. So now, what is x and y here? Now it should be easy. So just mod v cos theta modulus v sin theta. And how do you see? A hint, let me give you hint. If you have any vector v1, v2, okay, and if I, what is the norm? Now can you relate this thing, that how would you write your vector? Okay, maybe you go back and see in the many trigonometry book, it's very simple to see that how to see this vector using trigonometric ratios, and then you will get this. All right. Okay, another question is find the component form of a vector which has magnitude form 4 and it forms an angle minus 45 degree with the x-axis. Can you tell me the component? Yeah, it has something to do here. If you understand this part, then this part will also be easy. If you see carefully, the distance is nothing but just V1 here. This just is just V2 here. Okay.
4
And
by
therefore,
root 2 and 4 minus 4 by root.
okay. How did let's see what you are doing. We want first of all an angle with minus 45 degrees. So let's draw this. We can draw this. Where is minus 45 degree angle with the x-axis?
In the fourth quadrant.
Fourth coordinate. How much should I like?
Fourth quadrant, like you have to go for 45 degrees down.
Right. So if this is my plus 45 degree, then this is my minus 45 degree. All right. So this is my minus 45 degree angle, and of course we have to make it with x-axis. This is what given to us, and magnitude we have to go till 4 only. So let me just say simply, I can't draw it here, but let's see that suppose this is my magnitude 4 vector. So can you tell me the component? How would you tell the component? Yeah, in order to know the component, you should know the distance this and somehow this, okay, which is somehow parallel to this. If you can get the first coordinate and the second coordinate, then you can write a component form. But just now we saw that first component can be written with the help of sine and cosine. What is that? So it's given that magnitude is 4. This will help you. Yeah. Can you tell me now?
4 cos theta, so 4 cos 45.
Right. So your first vector is vector mod cos of your minus 45 degree. And then again your vector mod and then sine of minus 45 degree. What is cos of minus 45?
1 by root.
1 by root 2. Okay. So 4 by root. And what is sine of minus 45?
Minus 1 by root.
This is minus root 2. Very good. So what will the final, can you simplify more, or I think we can leave it here also. Or if you want to simplify more, you can just rationalize it and then you can say this is nothing but 2 root 2 minus 2 root 2. Okay. Alright, so therefore now we know how to compute a component form with the given angles and with the given magnitude. Once we know the angle and magnitude, we can write the vector. Both are necessary. Both are necessary for us. Okay, so a unit vector, just some definition. A unit vector is a vector with magnitude 1. And suppose a vector has magnitude not equal to 1, then we can simply divide that vector by its modulus, and that will become a unit vector. Do you agree this? Do you follow this line? Let me highlight this line. Okay, let me try writing this. So suppose V is nothing but V1 comma V2. Then what is the magnitude? It is simply V1 square plus V2 square. And if I just divide by its norm, then it will be V1 comma modulus V1 square plus V2 square, V2 comma modulus V1 square plus V2 square. Now if I try to compute its norm or its modulus, whatever we say, you can just simply write one time also. So what will that be? Can you tell me now? Suppose I divide our vector with its norm and finally take its norm. What will that be? If you see, it is nothing but V1 square by V1 square plus V2 square plus V2 square by V1 square plus V2 square, yeah? squaring up this vector, squaring up this vector, and then add up. This is nothing but v1 square plus v2 square by the same term. And what is this? 1. So if any vector we have, if I divide by its norm become 1. I mean, it becomes a unit vector. So question 9 is find a unit vector v in the same direction v where v is 1, 2. Suppose we are given one vector v 1, 2. Can we find a unit vector with the same direction of v?
One by root 5 times v.
1 by root 5 times
V.
Okay, how do you get it?
Just by the formula. Root
Okay.
over 1.
So how do you know that this vector will not have a different direction?
Because we are just like whatever our original vector was, we are just scaling it down to the unit. So we are just applying our old scalar multiplication rule here.
Right. Since mod v is nothing but a scalar, so what we are doing is we are just multiplying your vector by a scalar. This is a scalar quantity. So therefore we are scaling up a vector which will not change the direction, which will just change the magnitude. And since we just saw that magnitude of such a vector is always 1, so therefore it is just need to compute, unit just need have to compute the vector divided by its modulus. So if you see, the modulus of this vector is nothing but 1 plus 4, which is just root 5. And therefore 1 comma root 5 comma 2 comma root 5, this is your unit vector. And it has same direction because of the same reason. Alright, so we know this. Now another part is find the vector w with the same direction as v with its modulus value is 7. Suppose I want a vector having same direction of v, but its modulus value is 7. Then what will we do?
I think we just have to multiply the unit vector by 7.
Sorry, sir. You are very fast.
We have to multiply the unit vector by 7.
Right. So since we just got a vector with the same direction of v and has magnitude 1, if I want its magnitude to be 7, multiplying by 7 will give me that, right? So 7 times my v by mod v, this is nothing but my w. And if you see its modulus, it is nothing but 7 only. Alright, so these are certain simple things. So let's go ahead. So finding, there's another concept which is we trying to understand here, finding angle with which vector makes with the x-axis. Suppose you are given a vector and you want to find what kind of angle it does it make with the x-axis, okay? We are trying to understand certain facts and then we'll come back to question. So any vector, suppose I'm writing cos theta sin theta, you can always write in the form of your I cap and j cap. And of course is a unit vector, and in fact this vector lies on the unit circle, okay? All the points are of the form cos theta comma sin theta for a appropriate theta. Now if I take any vector v which is x prime I cap plus x j cap, let's say, and then if I take w, then w is a unit vector. Given any vector, we got a unit vector. And also I know that any unit vector, it should lie on a unit circle. Therefore, its components should be of the form cos theta comma sin theta. And this will in turn tell you that you can compare theta from here and get back your angle. So somehow the idea is, suppose any vector you are given, what would you do? You first make a unit vector out of that. You compare that vector now with the cos theta sin theta and then find your theta, which will in turn tell you what is the angle between the vector and the x-axis. Is this okay? Is the idea clear what we are trying to do? Any vector, we are pushing it to the unit circle, and there I know that any vector on the unit circle has to be of the form cos theta sin theta, and then I will simply take what is the theta from there. And since you know how your W and V are related, okay, so then you can somehow get your angle between V and as well as your x-axis. So this is what the idea, we are trying to use the same idea to find the angle between the vectors, like what vector makes with the x-axis, let's say. So suppose we understand this concept. Question is, given vector is 3i cap plus 4j cap. Can you tell me what theta does it, what the angle theta between this vector and the x-axis?
Ma'am, the unit vector is 3 by 5, 4 by 5. So cos
Right.
theta is equal to 3 by 5. So cos inverse of 3 by 5.
Okay, let me just, so here vector is nothing but 3 comma 4, 3 comma 3 comma 5, 4 comma 5. That's correct. And then what did you say?
Since cos theta is equal to 3 by 5, we got
Yeah.
that 3 by 5. Cos inverse of
Yeah.
3 by 5.
Right. So this lie in the unit circle. So this will belong to S1. I think this is the x comma y such that x square plus y square equal to 1. So therefore it lies on the unit circle, and therefore it should have a coordinate of the form cos theta sin theta. So comparing, I will just simply get cos theta sin theta 4 by 5, and here I can get cos inverse 3 by 5. Or you can simply say this is also same as sin inverse 4 by 5. Okay, we can just leave simply here. We don't know what are these values. So idea wise, it's okay, right? How to compute the angle.
Ma'am,
Yeah.
like why are we taking cos theta comma sin theta only? Why can't we like, is it just a convention, or we can also take sin theta comma cos theta?
Mm, well, the way we write points are like cos theta sin theta only. This is what we do. It's because of, I think it's because of this reason that this point is always your x cos theta, and this is always your x sin theta. It's not convention, it is following through trigonometry only. And therefore your first coordinate has to be cos only, not sine. And another thing is that no, somebody can notice how are we computing this is because we are not changing. If I suppose if I change my vector v by taking its magnitude, another vector, okay, this is another vector now, direction is not going to change. So the theta is not going to change even if I change my vector by just simply scaling it. So this is why the way that we are doing finding the angle, direction is not changing even if I'm changing my vector. The original vector has been changed. So, but the convention which you are asking, I think it should be cos and sine. It cannot be sine comma cos. So, and it is because of this reason. Your first coordinate has to be from the, if you see this point, this vector is always your x cos theta, comma x sine theta. You cannot write sine and cos, right? You cannot write that.
Yes, I get it.
Yeah. Okay. So, all right. So then we know how to find an angle which a vector makes with the x-axis. So this theta is the angle. All right. So I think that's all I want to discuss. Do you have any doubts, or maybe let me also see if I can ask some more questions. Yeah. Do you have any doubts apart from that geometrical? How cross product and dot product we can see. Maybe I will see it. I right now I don't know how to show it, but I will see it.
Ma'am, like, hello.
Yeah, yeah. Say it.
Yeah, so like there is a question in the this assignment that we have
Mm-hmm.
to find the area of the triangle. Triangle. The coordinates have been given in three-dimensional space. So three coordinate points have been given.
Okay.
So like how do I like derive? I think I have to derive some formula for it first, and then I can do it. So like, can you explain me how I can do that?
Oh, there is a triangle in R3.
Yes, like three
Okay.
coordinates have been given to
Okay.
me, and now I have to compute the area of triangle.
Okay. So if we try to do in R2, suppose we have 1, 2, 3. This is 2, 3. This is 3. How would you find the area here? I think if you understand this part, you can tell that part also.
Like for here, like I have like two vectors. So one has like 1 and 3, and this like I will take two vectors, complete the parallelogram, compute the area of parallelogram, and I will be done.
Okay. So what about then R3? You won't say that. So you have 3 points are given to you, right?
Yes.
So let me assume that one point is this, another point is say this. Say here, one point is let me say okay. Mm, suppose this is the third point. Okay. So can you do here? I mean, can you repeat the same idea here itself? Like, why not the same thing? Suppose this is my triangle. I want to find the area now. What you did is this, right? You completed it and then try to find the full area and then find and you just cut it half by that and then you got the area. Can you do similar thing there?
Now, yes. Fine.
Can you tell me now? I mean, I am somehow I'm not sure.
Like if I label these as points as A, B, and C, it- well, they will be they are three-dimensional, so there will be three tuples.
Okay. Oh, sorry. Yeah. A1, A2, A3, A2, A3, C2, C3. Yeah.
So like we can do A vector minus B vector and P vector minus B vector, and then we can, I think so, complete the parallelogram and compute the area.
Okay. So, okay. I think if you understand that, better you find the area and tell me next time about that. So, that assignment, till what time you have to solve it?
7th of August.
7th of August. Okay. So, we are meeting before that, right? 7th of I think we are meeting before that because next tutorial is again on Saturday. So I hope that you will tell me. Otherwise, I will tell you two ways for this. You can compute, there is a formula also. If you don't want to use the formula, you can also do it geometrically the way you did it. So let first you try, and since you got the hint by looking from R2 to R3, if you can compute it, otherwise I will tell you. I don't want to, because you have to think it before I tell you. Okay, any other thing? And how, like, who gave you this assignment question? Sir only gave you?
It's there on the portal.
Okay, they're in the portal. All right, all right. So there is a okay, and you have to solve by 7th of August. Okay, I think pretty enough time. Mm. Any other doubt anybody has? There is a general formula, by the way, for any n dimensional. Let's say you have a triangle in n vectors, n components. Even then you can solve it, but it's not that easy. But yeah, there is a formula for it. One more thing, if you want to see this part, let's say once again, you can do one more thing. Suppose your triangle, okay, just suppose your triangle is this, then you can simply fill up this and not filling it correctly, but yeah, if you have to, you can fill it, and then if you can finding the areas of these, and then if you can find the area of full figure, then you can take the difference, and somehow you have to get the area by knowing the area of certain object which you know. Okay, and if you can fill your figure in such a way that where you know the area, then you have to just simply either take the difference, or you have to half it, or like that you have to do it. Maybe it's good that you take some example and do it, then it will be very easy to see. This is my suggestion for now, because if you know this dimensions, you know the points where this the way the triangle has been formed, then you can also get these other points, okay, that you can also get it, and therefore you can complete the figure, and then you can know the answers. Does that help you? I mean, is that okay?
Yes.
Okay. And next time I will tell you the formula also, like how to directly compute without geometrically. But you try and give me answer first, then I will tell you. Okay, in this assignment, I think this what we discussed, that was pretty simple. Those all things were pretty simple. And one question is left, that I will tell cross product and dot product. All right, so is that all? So can we close the session now? Because I also don't have many other questions. So. Yeah, can we close the session? All right, so if no further questions, so I'll just stop the recording, and then we can